Welcome, happy learners, to another Desmos demo. Let's start by clicking on the 3-bar menu. That opens up the ability to create a new blank graph if you need to. If you scroll down, you can see your saved graphs. I have a few. And then you also have examples that are always provided from Desmos. Stuff like plotting lines, parabolas, a little bit of trigonometry, conic sections, polar curves, parametric curves, transformations, some statistics, and here is what we want to talk about, lists. So if you click on any of these graphs, you then need to open it. And then we have this nice sinusoidal wave that we're looking at, but we have multiples. And we see that there in the first box, there's an A defined. This is a list. And it says that A is a 16-element list. We look inside the square brackets, and we have a beginning value of 1, an ending value of 4. From the 1, the next value is 1.2. So what it's doing is it's going from term to term by adding 0.2. We can change that value, maybe do 1.5, and now we have a list containing 7 elements. And if you were looking at the graphed curves, we have now 7 curves plotted instead of 16. So we can change that maybe to a 1, and then the next value, let it be 2, and that's counting by 1. And then we just have 4 elements. Now, what we're doing, or what this example has, is setting y equal to A, which is a list. So it reads through the list and picks each of the values and creates a new amplitude. So if we were only to go from 1 to 1, there's no use in this list, that we just get the regular sine wave. If I make that into a 10 or a 100, then I have my list of 100 elements, and I have amplitudes which go from 1 up to 100. All right, let's look at some of the others. That's one way to use a list. Here's another example of curve stitching. We can play around. We try the same thing, 1 to 1.1, for example. And then we just get a finer mesh here. They have a couple of comments here. If we plot the third box, we see that we get entire lines drawn. Let's bring this back to counting by 1 so it's easier to look at. So we have the blue curves, which are just lines. And then the red, what the red is doing is it's using a restriction. It's saying, I only want to plot this first curly brace, is requiring that we only plot in the upper half plane. If we get rid of this piece here, then only in the right half plane. Then if we bring that back, the y greater than 0, that is plotting in the upper half plane. Get rid of the restriction on x, plotting only in the upper half plane, and the positive right plane means that we're only plotting in quadrant 1. Nice. Try another one. They have one more. And here, if you are studying second semester calculus, where you need to go over sequences and series, this use of the list is rather nice. Okay, so note that we can plot out a parabola. This is defining a function f. Let's get rid of the dots. Defining a function f as 1/4 x squared. And then it is plotting particular points on this curve. Well, what points is it plotting? It's plotting x values as a. And then what are the a's? The a is a list of a number of elements, starting at 0, counting by 1/10 up to 4. And then for the y value, what is it doing? It's plugging in a into the function f to produce a y value. We can look at labels. It's a lot to look at. Let's go and count by 1. Then we have nice labels on each of these, where the x-coordinate is a value from the list, and the y-coordinate is the output of f. Very nice. So all of these can be found, the 3 bars, in the examples from Desmos. Like and subscribe if you find this useful.